Are you confused about the differences between tf.nn conv2d and tf.nn.depthwise conv2d in TensorFlow? You're not alone. Many developers find themselves puzzled by these two functions. Today, we're going to clarify their differences and help you choose the right one for your projects. I totally get it. When you're deep into coding and trying to optimize your neural networks, the last thing you want is to be stuck on understanding the tools at your disposal. This is a common question among TensorFlow users, and it's important to get it right. Let's dive into the specific question at hand. What is the difference between tnn conv2d and tf.nn depthwise conv2d? Understanding this can significantly impact how you design your models, so let's break it down together. To understand the difference, we need to look at how each function operates. tf.nn conv2d performs standard convolution, which applies a filter to the entire input. On the other hand, tf.nn depthwise conv2d applies a separate filter to each input channel, which can be more efficient in certain scenarios. Stay with me. By the end of this video, you'll not only understand these functions, but also know when to use each one for optimal performance in your models. To understand the difference between tf.nn and tf.nn depthwise conv2d, let's start with tf.nn conv2d. This function performs a standard convolution operation on a multi-dimensional input, typically used for processing images. In tf.nn.conv2d, the user can apply multiple filters to the input. Each filter can learn different features from the input data, which is essential for tasks like image classification. Now let's discuss tf.nn.depthwise conv2d. This function is designed for depthwise separable convolutions, which means it applies a single filter to each input channel separately. The user should note that depthwise convolutions are more efficient in terms of computation and parameters, especially for models that require lower resource usage, such as mobile applications. In summary, while tf.nn.conv2d applies multiple filters across all channels, tf.nn depthwise conv2d applies a single filter per channel, making it a more efficient choice for certain applications. Fun fact: depthwise separable convolutions are a key component of models like MobileNet, which are designed to run efficiently on mobile devices. So understanding these functions can really enhance your model's performance. Now let's look at the answers provided by other users. This user explains that tf.nn.depthwise conv2d uses multiple filters for each input channel. Specifically, it applies n different filters, resulting in n times the channel multiplier for the output channels. They suggest running the provided code to see the results. Here's a pro tip. When working with large datasets or deploying models on mobile, consider using tf.nn depthwise conv2d to save on resources without sacrificing performance. And there you have it. You now understand the key differences between tf.nn conv2d and tf.nn depthwise conv2d. Remember, choosing the right function can make a big difference in your model's efficiency. If you found this video helpful, don't forget to subscribe for more insights and tips.